Good evening, ladies and gentlemen. Experiment 22 this week. We're going to test Markovnikov's rule. Hopefully, you remember back on when you studied the reactions of alkenes that the Markovnikov rule simply stated that if you had a compound, if you add, uh, to an asymmetrical double bond, a asymmetrical reagent, that the hydrogens will, if hydrogens in the asymmetrical reagent, will attack or will go to the carbon that already has the most H's. So we're going to very simply make an alcohol by adding, the standard method is just add water to a double bond. But another method was developed in 1959 by a chemist called HCB, which is one of your questions. Who is the famous HCB? The only thing I can give you is he's very famous in this state. Um, so, uh, and you should be able to find out who he is pretty easily. So he developed a method by which we do what is called hydroboration. And hydroboration, uh, very simply, you may remember that one also from your lessons. It's a two-step. I'm just showing you this Wikipedia entry. Two-step organic reaction that converts an alkene into a neutral alcohol by the net addition of water across a double bond. So, just keeping that in mind, what we're trying to prove is his method in 1959. Markovnikov pretty much, he just did it with water and things like HBr and HCl. He really didn't know about these sophisticated additions that were a reaction that caused another reaction. So our question is, and you may already know this answer before we begin, if this is one you studied, is the hydroboration of an alkene a Markovnikov addition, or is it due anti-Markovnikov addition? Something like you probably remember for there are other ways to do it. If you'll remember, you could use peroxide um, to do that, the anti-Markovnikov addition. So the big question is the hydroboration of an alkene a Markovnikov addition or an anti-Markovnikov addition? The way we're going to identify this is two ways. Boiling points, you're going to have to pull out the old micro boiling point technique. I know you hate that one. And then also we can get some evidence from our IR on our liquid once we get it finished. In the IR, what we find out is that if it turns out that, so we're going to use one hexene, and if we produce the primary alcohol, we should see a band in the IR spectrum somewhere around 1050. If we have a secondary alcohol, we should see it at around 1110. So we should have two pieces of evidence that will prove the boiling points are far enough apart, 140 and 157 and a half, that you should, if your stuff starts to boil around 140, you've probably made the secondary one. If you have to hold on and get to closer to 160, if you zip by 140 and nothing happens, then you've probably formed the primary alcohol, which would be the anti-Markovnikov product, and the the secondary alcohol would be the Markovnikov product. So that's our goal in this experiment. The methodology is super long. We're going to have to do this in 2 nights, and this first night is long. So I'm going to try to get there as quickly as I can, and if you can get there before 5, I would recommend it unless you want to be there all night, because we're talking a good 2 hours worth of time on the in just reaction time. That's not setup and tear down. And then we'll finish analyzing it on the following week. So it'll be a pretty short night the following week. I'm giving you this. I've kind of summarized the procedure into some steps, and what I can do with that is I think what I'll do is we'll go ahead and just start here, and then we'll probably have to continue it in the second part of this video. So there's 3 calculations you have to do this time, 3 calculations. We need to know what the mass of 4 millimoles of iodine are. We need to know what the mass of 20 millimoles of 1-hexene are. And we need to know what the mass of 8 millimoles of sodium borohydride are. And there's some information in there in the reaction that talks about some of the things that are going on. And there's some chemicals you need to be careful with in this one. Pretty much everything's a mess. The tetrahydrofuran's not good for you. The iodine's not good for you. The 1-hexene's not too bad. And sodium borohydride, not a great compound in itself. So this is one of the lesser green labs that we've probably done. So we've got 30 or 40% hydrogen peroxide, which will immediately make your skin white upon contact. So they'll bleach your skin. So you definitely have to have the gloves on at that portion of the program when we go through it. So I'm just going to kind of run through this a little bit. So 4 millimoles of iodine, dark purple crystals. If you spill these, make sure you clean them up because these are not good out in the room. Dispose of them not in the garbage cans. If you do dispose of them in the garbage cans, make sure you wrap them in paper towels. So be very careful on this if you spill them over on the balances and stuff. Since we're the only ones using this, I want to know if you spilled it or not. So make sure you clean that up. Screw cap vial, mix that with 5 milliliters of THF and make sure you get all that dissolved in there. You're going to put this into separatory funnel later. Then assemble a reflux addition. Obviously we'll have the water on, 100 milliliter flask. I would rinse your flask with a little THF just in case there's something left in there from other experiments. 20 millimoles of 1-hexene into the flask, and then 25 more milliliters of the THF. So under the hood, add 8 millimoles of sodium borohydride to the flask. Then you're going to bring that back to retach the apparatus, cool it in an ice water bath, and run your reflux during this time. Then put the iodine into the separatory funnel and add it in 20 drop portions. Add each of these 20 drop portions when one of 3 things occurs first. 5 minutes, it becomes colorless or becomes light yellow. Typically, I've found that the colorless or light yellow happens. So you can see right here, this could take up to 20 minutes to get this part done. And that's not, now, you've had your setup. Remove the ice bath and just stir it. Sit there on a stirrer for an hour. Take your quiz then. While this is going on, prepare a hot water bath, 30 to 40 degrees on a separate heating unit. Because you're going to want that ready so you don't have to wait for the water to heat up later. Now, this is going to be a tricky part here. Also during this hour, so you're taking a quiz, you're preparing a hot water bath, and at some point you need to remove the adapter in the funnel, attach the reflux condenser directly to the flask, and rinse the adapter in the funnel with acetone, dry them with air, and put them back on. So you're going to be busy during that hour. It's not just a sit-down hour, so make sure you get all those things done. All right, once the hour's passed, cool it again for 10 minutes, and then add 10 milliliters of DI water through the separatory funnel while stirring. Now, this is a tricky part. When you think the reaction's over, remove it from the cold water bath and continue stirring it until bubbling stops. Now, how are you going to know when the bubbling stops? Is you're going to have to actually stop the stir. You're going to have to look at the flask, and you're going to have to see if the bubbles are if it's still bubbling. Some people say they can tell. Most people have to stop it periodically. So once the bubbling is stopped, then this may take as much as 15 minutes for that part to happen as well. All right, my recording time is going to stop here, so I'm going to go ahead and stop this one.